We calculate the mass of oil because volume changes with temperature, but the mass, or weight, remains the same. We are going to use metric tons as our unit or weight, but a unit of barrels is also used in the oil trade. The ullages are obtained from the tank gauges. The ullage is the distance from the reference point of the tank down to the liquid surface. The tank level is then calculated by taking the reference height minus the measured ullage. The shape of the ship's hull affects the volume from the ullage. We use the ullage in the cargo tank calibration tables, apply the appropriate corrections for trim, shrinkage, expansion, and extract the volume of liquid in the tank. This will be the volume at the observed temperature. Remember, volume changes with temperature. As the volume changes with the temperature, this cannot be the measure of how much cargo we have loaded or discharged. We need to convert the volumes to the weight of the cargo in each tank. We need the density of the cargo to convert the volume of cargo to the weight. We also measure the temperature of the cargo, preferably at 3 levels, and take the mean of these 3 temperatures to get the temperature of the cargo. The temperature is entered on the ullage sheet. Density changes with the temperature. We get the density from the authorized laboratory where the samples were analyzed. The ASTM tables give the volume correction factors to find the volumes at temperature for which the density is given. The density provided is used on the ullage sheet. Table 54b provides the volume correction factors for us to convert gross observed volume to gross standard volume at temperatures other than 15 degrees Celsius to corresponding volumes at 15 degrees Celsius. In our example, the volume correction factor is 0.985 when the temperature is 31 degrees C, and the density is 0.816. Using the volume correction factor, we calculate that the 2103.5 cubic meters at 31 degrees will occupy 2071.9 cubic meters at 15 degrees. Less space at the cooler temperature. Apart from the units, weight is measured in air or in vacuum. It is more common to measure the cargo weights in the air. Sometimes you may find that the charterers would give the requirements for measuring weight in vacuum. The weight is vacuum is always more than the weight in air. The weight in vacuum is always more than the weight in air. The first page of the ASTM Table 56 provides the factor for converting weight in vacuum to weight in air and vice versa. For the method we are describing, we reduce the density in air at 15 degrees, by 0.0011 to get the density in vacuum at 15 degrees. In the example, we reduce 0.816 by 0.0011 to 0.815, and apply it to the standard volume to get the weight in air, in metric tons.